Hello, welcome to this lesson where we're going to look at how we can use completing the square as a method of factorizing. This is a method that we can use when PSF or the cross method doesn't work. So these are some of the formulas you're going to need to remember, which are the perfect squares and the difference of two squares. Now, this is an example of where PSF won't work. So here we have a product minus 2, sum of 6, and then there's no factors that we can find that work for this one. So we're stuck and we can't go further. We can't factorize it using PSF. You'll find the similar thing with the cross method. All right, this is just an overview of the PSF method. It's probably worth coming back here once we've gone through some examples to have a look at it. But basically, when we have an equation of this form, we can use completing the square. So it's a trinomial quadratic equation. The way that we solve that is we're going to add b over 2 squared. So we take the coefficient of x, it's going to be b over 2 squared, and then we need to also subtract it. So that's the second step. Because if we're adding something to keep the equation, the expression the same, or the same value, we need to then take it away. So this is like writing x and then changing the equation by adding 1 and subtracting 1. These two cancel out, so it still equals x. Here, these two will cancel out. Now we can go through the next two steps, which are factorizing using the perfect square. We'll have a constant remaining, so there'll still be a constant left over, and then we can use factorizing using the difference of two squares. All right, so this is the first example. Bear with me if you're still confused, that's okay. We're going to start by adding b over 2 squared. Now our b is this 6 here, the coefficient of x, so it's going to be 6 over 2 squared, which equals 3 squared, which is 9. So that's the number we're going to be adding. Now, we're going to rewrite our equation. We take x squared plus 6x. Now, I'm going to leave this constant, and I'm going to add our 9 first. Now we take put the constant in, and we also remember step 2 was to subtract this new number we've made. So we're subtracting the 9 as well. That means if we were to add these two up, they cancel out, and we still have an equation, an expression that is the same value as the first one. Now we can just consider this part, and because of the process we've used, we know that this is a perfect square. So we're going to use the factorization of a perfect square here to work out the next step. So this would be our a squared term, this is our 2ab, and this here is our b squared. So we will just go and we'll take x, because that's the square root of x squared, plus 3, and that's going to be squared. So this is using perfect square to factorize that equation. And then we get minus 11. Now the next step is to use the difference of two squares. But it's going to be different to how we've been using it up to now, because this number here isn't a perfect square. However, if you were to think of the situation where you have square root of 11 times the square root of 11, that's going to give you 11. So if we consider this term here as our a squared term, and then we have minus, then this one here, the 11, becomes our b squared term. If b squared equals 11, b is going to be the square root of 11. So we've got also our a squared equals x plus 3 squared. So therefore, a is going to be x plus 3. So we can now use the difference of two squares. So we've got, remember that's a squared minus b squared equals a plus b, a minus b. So we can then write our a, which is x plus 3, plus our b, which is the square root of 11, and then x plus 3 minus our b, square root of 11. And that is the factorized form of the first equation. Okay, this is another question. I'm going to go through it a bit quicker this time. So we're going to find the term we're adding. So remember, it's this 8 over 2 squared. So 4 squared, which is 16. Now we're going to rewrite it as x squared minus 8x plus our new number, which is 16, then plus the constant, and then, subtract 16. Now we make a perfect square out of this one. So we're going to take x. Now because of this minus term, it's going to be the negative perfect square, so minus 4. And that's all squared. And then minus 7. Now we're going to use the difference of two squares. if 7 is our b squared, then b is going to be the square root of 7. And our a is going to be x minus 4. So we get x minus 4 plus the square root of 7 times x minus 4 minus the square root of 7. And that there is our solution. The final example, again, I'll go through it quickly. So we're going to take our b, which is 4 over 2, and square it. So that's going to become 2 squared, which is 4. So we rewrite it x squared plus 4x plus 4, then minus our constant, and then minus 4. So that's step 2 minus 4. Now again, we just consider the first part. So we're going to go x plus 2, because this one's here is a plus, it's going to be a positive, a perfect square. And again, we work that out because this is our a squared term, so we know that a is going to be x. This is our b squared term, so we know that b is going to be 2. Then we can subtract 14. Now difference of two squares, we have a is x plus 2, and our b is going to be the square root of 14. So we go x plus 2 plus the square root of 14, x plus 2 minus the square root of 14. And that's the solution.